Hello everyone, this video is regarding the phase 2 of our final project of EE542 Internet and Cloud Computing at USC. My teammates are Ashwati and Drumal and myself Prem. In the last phase, we used the clustering analysis for by implementing the k-means clustering, which is a vector quantization on raw data to solve the problem of mislabeling, which leads to better classification, and the results that we got were not accurate. Here in this project, what we're going to do is we preprocess the data to remove the noise content using correlation between the parameters, and to view the correlation that has been implemented we use the heat map.
In the previous part, we did k-means clustering on the raw data to get 50 centroids, and each centroid having 181 parameters or the columns, which define the dimension of the axis. But that was the baseline experiment for this project. So now, in order to move forward, we are finding correlations between each of the parameters for each of the cases or the files. Doing this, we get to know that which of the parameters are highly correlated and are not. So using this, we will extract the features which are highly correlative, do PCA, which is principal component analysis, in order to reduce the dimension, and apply the previous technique of k-means clustering to get more accuracy. So in the previous part, we got like 50% accuracy. So we are finding the correlations, and after that we will plot the heat map. Heat map is just a way to see how are the correlations being showed for each of the parameters, and we'll get the parameters. So I'll just run the code. Running this code and generating the heat map for the parameters takes a while, but after that you'll see that the heat map what we get is is also very raw, because we are not taking the important features. We are taking like the features what we are getting for highly coded also are also many. So the next step is to perform principal component analysis, like to reduce the dimension, and then do correlations, and then do the k-means clustering. So in that, with every stage, we will increase our accuracy level, and at the final stage, we will train our data. We will use the data to train our algorithm to find the mislabeled files or cases. As you see, it's running. As you can see, the heat map is generated. Uh, so these are the features which have been selected for high correlation, but these are also are like too many. So this is what we have achieved in this step so far, and we would like to proceed with the PC in the next stage.
For phase 3, the immediate step would be to apply principal component analysis on our data. This, when applied, the maximum variance is extracted from the variables, or it can be explained as the direction where the data is more spread out. After applying PCA to our data, the next step would be to correlate the data for feature extraction. For this, we will be using XGBoost, which stands for Extreme Gradient Boosting. We are doing XGBoost to get a better execution speed and model performance. Thank you for watching this video.